Actually, it was 3 years ago. We went to a conference with Markus in Canada, and we went to the forest, and we got lost in a swamp. And so we were forced to think about that how we can support the growth of GeoGebra, and then that's how we thought about the International GeoGebra Institute, because we thought that we should be able to give the lead of the project to the local people. So people who are in countries and places know much better than what they need. So then that's why we thought about the International GeoGebra Institute, which is just an organization to try to give support for local communities and try to give support for the people. So we had a conference in Cambridge, and then we had the initial ideas of the International GeoGebra Institute. But now the institutes are growing. We have to reconfigure, and this GeoGebra Day is one of the aims of the GeoGebra Day, to find out that how we can manage this International GeoGebra Institute, because the number of institutes are growing. But the institutes, so there are already 4 in Spain, have 3 main objectives. It's teacher training and support, material and software development and research. So most of the institute do some of these works, but what we want to have is freedom of people, what they are interested to contribute to the community and share whatever they create. So, as I mentioned, there are already 38 institutes in different countries, but the numbers are growing, and then we try to discuss today that how and what we can do to support these communities. The other thing is the events. So it's similarly exploding as the software, so it's changing mathematics is taught. So last year we had 1 conference in Linz in Austria. This year we had about 10. So next year probably there will be about 20 or 25 conferences all over the world. So we already have proposals from Sao Paulo in Brazil, and Tehran in Iran, and in Serbia, in Novi Sad, and many other places. And we will have a big conference in Linz, so if you are interested in coming. And also, there are many other activities besides the development of the project. So there are at least 30 countries, which includes textbooks and online courses with GeoGebra. There is a book coming out about research on GeoGebra to give some theoretical background. We are having some special issues in journals with GeoGebra. There is online assessment tools like TAO and WebWork, and GeoGebra Tutor and Stack, which includes GeoGebra worksheets as a test for the work. So we are trying to work with developing countries. So there is a project in Africa which training teachers, and also we are having a GeoGebra addition to the 1 laptop per child project as well. And we are planning to have an online journal for teachers and for researchers as well, to contribute to the community. So it's very good that there is a big community, enthusiastic people, and thank you for contributing to the project as well. So I think Markus continues about the future of the project.
Thank you, Zsolt. Yeah, so I just would like to show some of the things that are going to be included in the next version, what we are working on right now. So what had happened this summer was a project that's called Google Summer of Code. So Google, you know Google, I guess. So Google is a big American company, and they are also supporting open source software development. And the way that they do it, as an open source organization like GeoGebra, you can apply for a grant to get some student programmers funded over the summer. So essentially their motto is coding instead of flipping burgers. So the students don't go to McDonald's to work in the summer, but they should do something more related to their interests and to their studies. So if they are computer science or mathematics students at the university, then they work in some open source project. And that's what happened. So we got 5 students working with us. So these students were from all over the world, and they applied over the internet to work with Geogebra. So we had set out a list of projects that we thought students could work with us. And then they applied to those projects, and actually many students applied. Over 50 students applied and wanted to work with us, which was very nice to see, because we have done it the first time, so we didn't know what to expect, if anybody would be out there interested in programming with GeoGebra. And out of these 50 students, we were able to pick 5. And these are the 5 people who work with us. One of them is also here from Spain. So you see there is a nice variety of countries also. So all of the students are from different countries. From India, Sweden, Germany, everywhere. And I will just show some of the things that they have been doing. So they have been working with mentors, so with people from GeoGebra who have been involved in the GeoGebra project for a longer time. And the mentors help the students to work on their projects and get something into the software. So one of the projects was implicit curves. As you know, in GeoGebra you currently can type in an equation of a conic section, an ellipse of a hyperbola, but you cannot use equations of higher degree. So if you type something like x cubed plus y cubed equals 0 or whatever, then it will just give you an error message. But in the new version in GeoGebra 4, we will have implicit curves, algebraic curves. So you can put in polynomials of higher degree and you get nice plots of them. And here are just some examples of such curves. So this was one of the projects. And the project that the student Sergio was working in Spain with Miguel, who is sitting here from Madrid. So Miguel was his mentor, and they were working on a project to find the equation of a locus line. So here on this picture you see this red locus line. So locus line is somehow constructed in GeoGebra by moving points around, and then you have another point describing a locus line. But what GeoGebra is doing at the moment, it's only drawing this line. So you see the picture, but you don't know the equation of this line. And sometimes, for some, at least for some special cases, it would be nice to be able to get the equation of this line. And this was a project that they were working on, and they have been able to put together a nice prototype, and we've just discussed and would like to continue this project so that it can actually go into GeoGebra 4, so that it will become a command in GeoGebra to ask for the equation of a locus line. Another project that has been going on over the summer is concerning touch. So more and more devices are now using touch screens and pens, or tablet PCs, and also interactive whiteboards when you're able to, use a pen and use your computer on the whiteboard. So for those environments, you usually don't have a keyboard right next to you. So what we did is we added an on-screen keyboard in GeoGebra, so you can use the keyboard with your pen or with the mouse, but typically with the pen when you're in such a tablet environment. And we've also started to play a little bit with handwriting recognition, but this is something for later. But the keyboard will be in the next version. Another big project in the background, which was also one of the Google Summer of Code projects. So one of the students was working from André from Sweden. He was working with Mathieu from France. So you see, it's also very interesting to see those people sitting in different countries. So they never met. All of the communication between the developers also works over the internet, sending emails, talking on Skype over the internet. So I have never met, I think I've met Mathieu. Yeah, of course I have not met the students, so I haven't met all of the developers myself. So actually next year at the conference that Zsolt mentioned in Linz, we will try to get all of the developers together in one room for the first time, because we have never been able to do that before. So that would be nice, and have a beer. So GeoGebra 3D is about having a dynamic geometry environment in 3D. At the moment in GeoGebra you can do 3D constructions. You can fake it, so you can do like 2D